Today we are going to discuss about example on theories of failures part 3, and we are going to discuss this problem in this session. So welcome to my YouTube channel Mechanical Engineering Management. The description of the given problem. The dimension of an overhang crank are shown in figure. There are the two views, front view and side view. The force P, that is over here, acting at crank pin is 1 kilonewton. The crank is made of steel 30C8 with allowable shear stress 100 megapascal. Using maximum shear stress theory of failure, determine the diameter at section XX. So we want to find the diameter of this pin at section XX, and that is the bearing support. Assume all dimensions are in mm. So here the important part in the description is what? Using maximum shear stress theory only. Given data. So P, that means the force, is given to you as 1 kilonewton. Then shear stress is given to you as 100 megapascal, and megapascal, that is Newton per mm square. Next, determine the diameter at section XX. So this D is equal to question mark. So as you know that maximum shear stress tau max is equal to this equation. Here if I want to find the tau max, then I have to find sigma x, then sigma y and tau xy. But you know that sigma y is equal to 0 because of there will be no any stress in the y direction. And sigma x, that is the bending stress, and if I want to find the bending stress, then I can use this fundamental equation of bending moment. M by I is equal to sigma by y. But here in this description, bending moment is directly not given to you. But you know that if the P, that is the force acting at the center of the pin in the side view, and in the front view it is acting over here perpendicular to this plane. And you know that bending moment is equal to what? Force into distance. So is equal to force that is given to you 1 kilonewton. So it is 1 into distance. Now distance is what? So that is acting over here, and we want to find the diameter over here, and that is supported by the bearing. So the distance from P to this bearing, that means perpendicular distance from the force, and this distance is what? From here to here. Because of, try to understand once again, if the force is acting over here, then the pin will bend from this support due to this load P, and that's why this distance is affected. And this distance is what? 50 plus 25 plus 100. So that is 175. So I can put it over here, and so that I will get 175. But keep in mind the unit. We have taken force in kilonewton and distance, that is in mm. So your unit for the bending moment is what? Kilonewton into mm. This is my earlier slide. Now I can use this equation, fundamental equation of bending moment. So you have now bending moment 175 kilonewton, that's why it is 10 raised to 3 upon moment of inertia I, and for the circular pin you know that moment of inertia is pi by 64 d raised to 4 is equal to, as it is, sigma x, that is my objective, upon y, it means this distance, neutral axis to extreme fiber, and that is d by 2. So if you simplify this equation, then you will get sigma x in terms of diameter. So similarly, I can find the shear stress from the fundamental equation of pure twisting. So I can say T by J is equal to tau by R. So once again over here you have to find the torque, because of it is not given to you in the description. So you know that torque is equal to force into distance. But here the force is given to you as 1 kilonewton. So I can say 1 into. Now what is the distance? Can you imagine for the torque? So the force P is acting over here, and due to that force it will tends to rotate with respect to this axis because of it is the bearing support. And so that your effective radius, that is this one, and that's why the distance is what? 500. And so that you can imagine that will be your effective radius and that will be your distance, and that is given to you as 500. So what is the unit of this one? So we have taken force in kilonewton and distance in mm, so it will be kilonewton into mm. So now I can put it over here. So T is 500 kilonewton, that's why it is 10 raised to 3. J is the polar moment of inertia, and you know that for the circular cross section, polar moment of inertia is pi by 32 d raised to 4 is equal to, as it is, tau is my objective, and you know that radius is d by 2. So if you simplify, then you will get tau in terms of diameter. So once you got that sigma x and tau, then you can find tau max. So now I am going to find the tau max. So maximum shear stress tau max is equal to sigma x by 2 plus tau square xy, because of sigma y is 0. So now put this sigma x is equal to this and tau is equal to this one in this equation. So now in this equation, maximum shear stress, that is also given to you, allowable shear stress, that is what? 100 megapascal. So I can put it over here, shear stress maximum as 100 is equal to sigma x by 2, sigma x you know that, by 2 as it is, plus tau square you know that. So now if you simplify this equation, then you will get d. So first you will get d cube and cube root of this, then you will get d, and that is 29.99, that is nearly equal to 30 mm. So this is your answer. Determine the diameter at section XX. So make a box. So thanks my dear friends, press the like button to appreciate this video.